Okay, so this is going to be our review for our quiz number 1, which is going to take place tomorrow, 9/13. And so the first thing that we got to make sure we know that is going to be on there is knowing pod C. You should be able to list what those mean. That's pretty easy. Briefly describe each step. What's the P stand for? Okay, so the first thing we do is we predict what's going to happen, make a prediction. What do we think will happen? So you're going to fill that in with a brief description. Okay, what is step 2 then? Observation, observe, right. So this is using our 5 senses, looking for details, as much information as we can get down, right? What is the third thing? Describe and discuss. And really what we're doing in this when we're trying to describe is we're really trying to explain what's going on. And being chemistry, which is the study of the composition of matter, we're thinking particle level for these explanations, just like these models that we're working on right now. Okay? Discuss is pretty self-explanatory. We talk about it. We share our ideas with each other. And then what is 4? Consensus. So in our sharing and discussing and debating, we try to come to a general agreement. Okay, so that's the first part that you should be able to do. Okay? Consensus? Now, the rest of it pretty much goes along with graphing. Now, on graphs, I'm going to talk about this more when we go to the graph. But one thing we got to understand is we got to be able to look at an experiment and identify some things in the experiment. What we should be able to identify in the experiment, first of all, is identify what the manipulated variable is. Okay? The manipulated variable, also known sometimes as the independent variable, that's the variable that we are testing. So it's a thing that we are changing on purpose. What we change on purpose. And we do have these in those notes. Don't forget those notes. I am going to collect those and give you points for those notes that we've taken so far. The graphing notes really is what we have. So this is what we test. We manipulate this variable. We change it on purpose. We want to see if there's a difference if we change this variable. All right. As a result of changing this variable, there may be something else that changes, and that would be the dependent variable. And the dependent variable changes because of the manipulated variable. Changes because of the thing we're testing, which is the manipulated variable. All right. The other part of these experiments that we should be able to identify are the constants. So the constants, things that stay the same. These are things that we are not testing. Okay? So we want everything to be the same between when we're making comparisons between two trials. We want everything exactly the same except for the one thing we're testing. So everything is kept constant. Right. So manipulated is sometimes called independent. I just like manipulated. I think it makes a little more sense. I also like dependent better than responding, just because it's easy to ask. A lot of times when you read through an experiment, does this depend on that, or does that depend on this? If that's not helping you, You just look at the experiment and say, what are they changing on purpose to start? Okay. Now, the reason why we went over these is because when we graph, we got to remember this thing, dry mix. And this is just to help us understand that the dependent variable goes on the y-axis. And the y-axis is the one that goes up and down like a yo-yo. All right? The manipulated variable goes on the x-axis. And that's the axis that goes side to side. Okay, like a xylophone. Cool. So this helps us set up our graphs. And so we got to be able to graph tomorrow. So if I look at our graph that we had on the height versus wingspan lab, these are the things that we got to make sure that we do. Number one, all graphs should have a title. Okay? Height versus wingspan, or maybe wingspan versus height, whatever. All right? We got to label the axes, and that's what we were just doing. We asked the question in class when we were doing this lab, which one do we think is the manipulated variable, which one is the dependent variable, and we kind of agreed that we said it sounds a little better to say that the wingspan depends on a person's height. So we ended up putting wingspan over here and height here. So step 2 is label the axes, but this is where you got to be really careful, and if you look at your graphs, a lot of people miss this. When you label the axes, make sure that you include the units. So we measured these in centimeters. All right, so make sure you put those on there. People miss that. The next thing is we got to make the appropriate scale. We got to make sure that we make each of these marks here worth the same amount. And we got to make sure that they go high enough to cover our highest point. We usually start at 0 here, 0, 0. We call that the origin. So I know on the height scale, we had to go up to pretty much 200 to cover all the data. So on this x-axis, we had to go all the way up to 200. I had to cover 200 units, or in this case, 200 centimeters. And since it's a pre-made graph for me, I had to count out all these marks here, counting all these across, and I found that counting all those across, I had 29 marks. So that means I have 29 marks to cover 200 centimeters. So to figure out how much each one needs to be worth, I can just divide it. I need to cover 200. I've got 29 marks to do it, and that came out to be like 6.89. I don't want to make each mark worth 6.89 because it's going to be really hard to do. All right? What I can do is I can go up from here, never down. I could make each mark worth 7, and I would cover my highest point. I could make each mark worth 8. 7 and 8, counting by those even, 7, 14, that doesn't work very well. 8 would be the same kind of problem, 8, 16. 9 would be the same thing. I'd go 9 and then 18. So I kind of advise that maybe we make each mark worth 10. Another thing is these marks are all really close together. So if I mark every single mark, 10, 20, 30, 40, I'm going to have a bunch of numbers all stuck together that are going to be hard to read. So instead what I'm going to do is just go like every 5. So 10, 20, 30, 40, 50. I'm going to label that. 60, 70, 80, 90, 100. 150. 200. And I don't even need to keep going because I know 200 will cover my highest point. All right? When I did wingspan, pretty much had to do the same thing. And that one, I only have 21 marks going up over here. So that came out to be 9 something. So I just rounded that up to 10 too. So 1, 2, 3, 4, 5, 50, 60, 70, 80, 90, 100, 150, 200. Okay? So now when we plot the points, let's say somebody, when I look at the data, I don't want to scroll down because my ink will stay here, but let's say we look at somebody and they've got a height of 185 centimeters and they have a wingspan of 190. Okay? So what I do is I find height. Where's 185? Well, here's 150, 160, 170, 180, 190 is right here. So I know that 185 is going to be somewhere in here. All right? Their wingspan is 190, so this is 150, 160, 170, 180, 190 is what this is. Here's 200. Okay, so 190 is right here. So what I try to do is I try to find out where those 2 points meet, which would be about here, and I make a point there. That's my data point. All right? And I would do that for all of the data. And I would end up like with points here, whatever. Then I had you guys draw a line through it. So you start at 0, kind of look at the data. Where would a line be that seems to go through the middle of the data? Again, it doesn't have to be perfect. You're just eyeballing it. All right? Now, on our data, we did once for boys, and then we did once for girls. Okay? Maybe theirs was something like this. Maybe their line was very similar, whatever. But then we also made a key. So in this case, red would be boys. Blue would be girls. And you could do it if you don't have different colors by making different marks. Like I suggested, girls, you could make X's and then make their line a dashed line or something. You could put all that information in the key so it makes sense. All right. Okay, so on the homework I just gave you guys, do I have time? Running out of time. All right, so let's look at this. Dissolving data. So we're talking about solubility, dissolving data for three antacid tablets. We have 3 beakers. We have original temperature that's different, and it's in degrees Celsius. We have 20 degrees Celsius, 30 degrees Celsius, 40 degrees. We have the time for the tablet to dissolve. So what do you think they're doing in this experiment? Are they changing the amount of time for the tablet to dissolve so that they can find the original temperature of the water? Or are they changing the original temperature of the water to find out how long it takes to dissolve? Temperature. So that means that temperature is going to be our manipulated variable, which means it's going to go here. Okay? Temperature, it's in degrees Celsius. We want to make sure we have a title. If you're not sure what the title is, just take the 2 variables. Temp versus time. It also tells us that we're dissolving something. Okay? Let's find our scale here. Okay, so my highest number I got to get to is 40. I got to cover 40 on this graph. How many marks do I have to cover 40? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so if I divide that, I could go by 4s. I don't like going by 4s. Let's go up. Let's go up to a higher number. Every 5 sound good? Okay, so again, I'm not going to mark every 5. I'm going to mark every 2 of them 10, 20, 30, 40. That's pretty good. So we're going to put the time over here, and it says that's in seconds. Again, I got to cover 40. Again, I've got 10 marks, so I can make those by 5s as well. So I had 40, 10 marks to cover it. 4, let's move it to a higher number that's easier to use. 20, 30, 40, and we're good. So the first one I'm going to plot is a temperature of 20 and dissolves at 40. So here's temperature 20. Here's dissolving at 40. Where do they meet? Boom, right there. Make a point. The next one, 30, 25. 30, go up to 25. Right here. And then the third one, we have an original temperature of 40. So that's here, and the amount of time is 10. So where do they meet? Right here. And this is going to be a line graph, so what I'm going to do is I'm just going to put a line going through those points, connect the dots. I have a title, check. I labeled my axes with units, good. I have good scale on it. I have the plots pointed. I have the dots collected. Do I need to make a key in this case? Okay, I'm only plotting one thing. There's only one measurement that we're making here. I do not need more than one graph. I do not need a key. And so that's how we do our graphing.